Hey guys, today we're going to take a look at how to find the domain and the range of a function. So first we have to know what are we talking about? So what do those words mean? So the domain are your x values of your function. Sometimes you'll also hear your input. The domain is the input, and it's also called the independent variable. So I want you to be familiar with all of those terms. The domain is your x values, your input, or your independent variable. So your your range, that's all of your y values. That's your output, or we sometimes refer to that as our dependent variable because it depends on the x or the domain. So let's take a look at how to actually find the domain and range of any given function. So let's use a little color coding here. Our domain we're going to highlight in blue, and our range I'm going to highlight in pink. So looking at number one, this table, we said that the domain is all of the x values. So all of our x values, we want to list from least a set arranged from least to greatest. So looking at that number or that table, we put a little brace. That's how you start a set. The smallest or the least number I see there is -11, and they're actually in order. -7, 3, and 6. So that set of numbers is the domain of this function. So now let's find the range or the y values. So again, we want to use or list that as a set. So draw your brace, ordered from least to greatest. Now this one's not organized from least to greatest. So my least number is -7, then -4, then 0, and then 5. So those are my range values of this function. So let's take a look at number 2 and look for our domain. So remember, the domain is our x values in our points. So we have -18, -27, 6, 3, and 9. So let's list those from least to greatest. Draw your brace. Looks to me like -27 is my smallest. Then -18, 3, 6, and 9. So now let's find our range or our x values. So I've got 6, 9, -2, -1, -3. So I want to list those. Again, draw your brace as a set from least to greatest. So my smallest number is -3, -2, -1, 6, and 9. So let's take a look at number 3. So let's find our domain or our x values. Well, they're all on the left-hand side. So let's list that as a set from least to greatest. So, and they're in order: -8, 2, 5. And let's do the same thing for our range or our y values. So from least to greatest, I've drawn my brace, and I have 4 and 7. So now let's take a look at number 4. We have an actual situation. So here's how it's just a little bit different in a verbal or a real world problem. We've got to think about the numbers that make sense. So let's read and see. Let's do our domain first. Let's see what's going to make sense in this situation. Charlie is going on a trip and needs to put his dog in a kennel. It costs $22 each day. Okay. He will be gone between 2 and 5 days. Make a table to find the domain and the range. Well, he's going to be gone between 2 to 5 days. That's going to be my input or my domain. So 2, 3, 4, 5. Let's go ahead and finish the table before we answer or identify our domain and range. So if it's $22 per day, I'm going to say 22 times 2 is $44. 22 times 3 is $66. 22 times 4 is $88. And 22 times 5 is $110. So now I can identify my domain and my range. So let's look at domain. The possible domain values for this problem are, let's draw our set, 2, 3, 4, 5. So days are my x values or my domain. Now let's take a look at the range. So my range or my output is my cost. So the possible range values for this problem from least to greatest are 44, 66, 88, and 110. So now let's take a look at how we would do this with graphs. So first let's look at this first graph, and let's actually find, I'm going to label domain and range. So here's the deal. When I have a graph that looks like this that have very distinct, or in math they're called discrete points, I always start off by reading my points. So this first one is -3, -2. I'm going to write it up here, -3, -2. The next one I see is -2, 1, -2, 1. I have a point at 0, 0. Then I see one at 2, 1. And the last point I see is 4, 1. So I start off by reading my distinct or discrete points. Now I do it just like I did above. All of my x values are my domains. Now you don't have to write the points as long as, like I just did, but it just helps keep me organized. So my domain values are, let's see what my smallest is. -3, then -2, 0, 2, and 4. So those are my domain values. Now let's take a look at our range values, all of our x's. So I've got -2, 1, 0, 1, 1. Now if you have repeats, you only write them one time. So let's start with the smallest number. The smallest number I see is -2. Next, I have 0, and I have 3 ones, so I only write it one time. So that is how, if you have distinct or discrete or individual points on a graph, that's how you identify your domain and range. But then we have these types of graphs. These are what are called continuous graphs. And I want you to focus, this is what I'm talking about right here. A continuous graph is like a line or a curve, or, you know, it's continuous. It doesn't have individual points. So we write the domain and range differently. We actually write the domain and range using inequality symbols. So just to remind you, our open circle, like if we have an open circle, it's either going to be less than or greater than. And if we have a closed circle on our graph, it's going to be less than or equal to, greater than or equal to. So now let's look at, how do I find the domain and range? Well, we know that the domain are the x values, and you will see that right here. So when I take a look at this right here, see the graph goes from here to here on the x-axis, so all of those are my domain values. Then if I look at that number line or the y-axis from here to here, see that? All of those are my y values or my range. So let's actually read this and write it the way it's supposed to be written. So let's start with our domain. I notice that the smallest x value that I see here is -1, 2, 3. So my domain goes from -3, and my highest x value is 1, 2, 3, 4, +5. And since we're talking about domain, we put an x in the middle. And let's think about this. X is greater than -3. Now watch how I do this. The open part goes with the x. So this means x is greater than -3, but it's reversed when we write it like this. Don't get confused. And it's an open circle, so I don't put the line. Now let's look at the 5. X is less than, see that? 5, and there's a closed dot. X is less than or equal to 5. So the way you read this is the domain is greater than -3, but less than or equal to 5. So now let's take a look at the range. And we're going to do more of these, but I just want to show you the initial way to read it. So our range, the top y value that I see, remember we go from least to greatest. So the least y value that I see is -1, 2, 3, 4, 5, -6. And the greatest y value I see is +2. And so y is greater than, and it's a closed dot, so or equal to -6, and y is less than, it's an open dot, so it's just less than 2. So that's how you write your range using inequalities. So let's practice finding the domain and the range of a couple more continuous graphs. So let's look at the first one. I'm going to go ahead and write domain, range. All right, so first remember, domain means your x values. So I'll start by writing an x. And I notice that this graph goes from -6 to +5, -6 to +5. I also notice that the dot on -6 is an open circle, so x is greater than -6. And I also see an open dot on 5, so x is less than 5. Now let's take a look at our range, or our y values. So first I write my y, and I notice actually I only see one y value. So I can write this a couple of ways. I can either write y equals -5, or I can just write it as that set, because there's only one number in that set. Now let's look at the next one. So first I'm going to start with my domain. The domain is your x values. So we go from least to greatest. So -1, greatest is 4. I see an open dot on the -1, so x is greater than -1. And I see a closed dot above the 4, so x is less than or equal to 4. Now let's look at our range, or our y values, on our continuous graph. So let me erase this. So the least, or the smallest y value that I see is a -4. And the greatest y value that I see is a +1/2. Because see, we have 0, nothing, and then 1, nothing, then 2, so those are halves. All right, so now let's write our inequality symbols. So I notice on -4 that it's an open dot, so y is greater than -4. And I notice a closed dot on the 1/2, so y is less than or equal to 1/2. So now let's take a look at one more idea. Sometimes instead of dots, you will have arrows on your graphs. And when that happens and they ask for the domain or the range, when you have dots, when you have arrows, that means that goes on forever and forever and forever. So the domain in this situation is all real numbers. So if you see an arrow, and it's going to be the same thing for the range here as well, because those arrows go on in both directions forever and ever and ever. So your range is going to be all real numbers. So let's practice finding the domain and range on continuous graphs that have arrows on them. So let's look at our first one here. So remember, our domain are our x values. Our domain is our x values. So I look at my least and my greatest, but because I notice that I have arrows on the end, my domain is all real numbers. Now let's take a look at our range. So we always go from our least value to our greatest. So our least value is 1. Remember, range is your y values, and our greatest value is 7. Now, even though we have arrows, we'll notice that it is darker. See how the line is darker here and here? So that means we're going to use y is greater than or equal to 1, y is less than or equal to 7. So even though we don't have closed dots, we can clearly see that those values are a part of our range. So let's keep practicing. So on the next one, our domain, or our x values, it looks like it goes from -5 to 5, but because of these arrows, our domain is actually all real numbers. Now we need to find our range, or our y values. Well, take a look at this. I only see one y value, and that's -3. So my range is y equals -3. All right, so let's take a look at another type of continuous graph with arrows on it. So first let's look at the domain. That's our x value, so it looks like it goes from -6 to +6, but because of the arrows, our domain is all real numbers. Now let's look at the range, or the y values. So I clearly see that the top is at +8, but I have these arrows at the bottom. The arrows are going down. So for my range, the way I would show this is y, since the arrows are going down, is less than, and see that this is dark, so is less than or equal to 8. So let's do another like that. And I'm just going to do a rough sketch of another one, another example. So we have, and we'll later learn that this is called a parabola. And let's say that it goes down to there, okay? So first let's find the domain. And again, because of the arrows, that's going to be all real numbers. And then let's look at the range, because this has a clear stopping point. If you look right here, the y starts at -1, 2, 3, 4. But then it keeps going up. So y is greater than or equal to -4.